Hello TNA, and welcome to lesson 3 of your energy topic for your GCSE level science. So hopefully you have your booklet open either from your teacher digitally or in a paper copy. And as always, before we start the lesson, you need to make sure that you have your pen and paper, a feedback color pen, and for this topic again, you will need your calculator with you. If you're using your phone as your calculator, make sure that it can do scientific calculations, so with squares and square roots, and put it on Do Not Disturb so you can focus on the lesson. Once you have that all sorted, I want you to give this knowledge check a try, pause the video, and answer the questions. So now you've hopefully had a chance to answer all these questions, and we'll go through the answers together, making sure you swap to your feedback color pen so you have the correct answers. The energy stored in a moving object is kinetic energy. The unit of elastic potential energy is the joule. Just like every type of energy, it's always in joules. A stretched elastic band has which energy store? That is our elastic potential energy. Make sure that you do have that potential written in there. If the extension of an object doubles, how much does its energy increase? The energy will square. Because remember, from our last lesson, our extension, we square it. So it'll increase by a squared factor. The pathway, when force moves through a distance, that is our mechanical pathway. We also have heating, radiation, and electrical as our other pathways. Remember that a pathway is how energy goes from one store to another. The energy store starting with N is nuclear, and with T is thermal. So we have our nuclear energy store and our thermal energy store. The energy store gained as an object is projected upwards, so as it goes up, that will have to be our gravitational potential energy. So make sure you have those ones written in, and then we'll continue on with the lesson. So as we already know, kinetic energy is the energy stored in something that is moving. So kinetic energy is the moving energy store. So if something is standing still, it has no kinetic energy. But as soon as it's moving, you've transferred energy to cause it to move, and it now has that kinetic energy store. So the kinetic energy of a moving object is equal to the work done by the object losing all its speed. So in order to get something to stop, the amount of energy you need to put in, the amount of work you need to put in to get it to stop is the amount of kinetic energy that object has. So for example, how much energy do you have to do to get the brakes on your moving bicycle to stop is the amount of kinetic energy that's there. You know, if you're moving a lot faster, you need to use a lot more braking power than if you're moving slower. So if you're moving faster, you have a higher kinetic energy than if you're moving slower. The same way, if you have a lot of mass, if it's a bigger person, it takes more energy to stop that bicycle than it does if it's a smaller person. So for example, a large truck driving at 20 meters per second has more energy than a motorbike driving at 20 meters per second because the truck has more mass. So mass is the first thing that really affects the kinetic energy. So the annotation, mass affects kinetic energy. All right. A sports car driving at 50 meters per second has more kinetic energy than a family car driving at 20 meters per second because it has a higher speed. All right, so the speed also affects speed. And remember, sometimes in science we use the term velocity to refer to speed. So the speed or the velocity also affects the kinetic energy. So the kinetic energy of a moving object can be calculated using the equation. So the same as we had an equation for elastic potential energy, we have one for kinetic energy. So the kinetic energy is equal to 1/2 times the mass times the speed squared. So this is an equation you will need to be able to memorize. So this is not one that they'll give you on a physics equation sheet. So you also have to think about, what do we measure these things in? So hopefully you remember kinetic energy. Kinetic energy, we measure it in joules. Mass, we measure in kilograms. And speed, we measure in meters per second. So we have our kinetic energy equals 1/2 mv squared. But remember, I don't want you to think about it as the letters. I want you to think about it as the full words when you're thinking about it, so that you're less likely to make a mistake. So kinetic energy is equal to 1/2 times mass times velocity squared. So once you have that equation and you know the things that go into the equation, you use the equation the exact same way as you do your elastic potential energy equation. So you always start with writing down your equation. So you read your question, you figure out what you need, what you have, and you write out your equation. So car with mass, 150 kilograms. We know that this 150 kilograms is mass. A velocity, remember, that's just another science word for speed, is 20 meters per second. We have kilograms, we have meters per second, so we don't need to change it. What is the kinetic energy? So we write down the equation. Kinetic energy is equal to 1/2 times mass times velocity squared. You plug in your numbers, so 1/2 equals 0.5 times 1,500 kilograms times 20 squared. That's something you can plug into your calculator, and you end up with 300,000 joules. Don't forget that you always need that final unit for that value. So, pause the video, answer this checkpoint question. What is the equation for kinetic energy? Give your SI units. Remember, that is your scientific units for all the quantities. Remember, quantities is the fancy science word for numbers involved. So pause the video, come back, and we'll go over the answer for that. So the equation for kinetic energy, if you don't remember, add it in with your green pen now, is we have our energy with our little k for kinetic is equal to 1/2 times mass times velocity squared. So kinetic energy, our scientific or our SI units, is joules. For mass, our SI unit is the kilogram. And for speed or velocity, it is meters per second. So that is the equation for kinetic energy with all the SI units. So now, here is just some simple calculating of kinetic energy. So these are reasonably straightforward. You can just plug it into a calculator. Once we get to the word problems, it will be the 3 steps that we've talked about the last couple lessons. So kinetic energy is equal to 1/2 times our mass, 2 times velocity squared, 10 squared. So you know that you need to use BidMass. So the velocity, so 10 squared is 100, times 2 is 200, times 1/2 is 100. Joules is our kinetic energy there. Pause the video, go through the next couple, and then unpause and check your answers. So here we have the answers for those 5 questions, making sure that you do have the correct answers written in your green pen. And I just noticed I have missed out a joules for that one, so it is 224 joules. If you forget the unit, you will not be able to get the mark. Looking at this next question, this one involves quite a bit of thinking. So a horse and a pony walk across the field at the same constant speed. So we know that the speed is constant, so that doesn't matter. The horse has 400 joules of kinetic energy. The pony is half the mass of the horse. What is the kinetic energy of the pony? So because we're not squaring the mass, we're simply multiplying it. If you multiply a number by half, you end up with half the amount. So the correct answer here would be 200 joules. And the reason why, if you half the mass, the total kinetic energy also halves. So that is the reason we're looking for there for that one. So looking at these word questions, remember the 3 steps that we will need to do. So remember, step 1 is, what do you know or not know? Question 2, what is the equation? And the step 3 is solve it, which is plug in the numbers and make sure you have it. So we'll do the first one together. The speed of the rocket just after being launched is 12 meters per second. So we'll highlight 12 meters per second and we'll annotate it with our V for our speed. The mass of the rocket is 0.05 kilograms. So we know this is the mass. Calculate the kinetic energy of the rocket just after being launched. So our kinetic energy, we know, is our unknown. We don't know what the kinetic energy is. So that's step 1. Step 2, write down our equation. Our equation, as is for every single one like this, we have our kinetic energy is equal to 1/2 times mass times velocity squared. Now I'll leave you to plug in those numbers and collect the correct answer. Pause the video and come back to it. So hopefully now you've plugged in the numbers you need to. So the kinetic energy is our unknown, so we're going to leave that as our question mark, equals 1/2 is the same as 0.5 times our mass, which is 0.05 times 12 squared. So remembering bid mass, you start with putting 12 squared into your calculator, and then you multiply that by 0.05 and times 0.5. So our kinetic energy, once you pull that all out, is 0.36 joules. Remember, no unit, no mark. So you have 1 mark for writing down the equation, 1 mark for putting in the numbers, and 1 mark for the correct answer. So we'll look again. We'll highlight the numbers we need to know. We have a mass of 300 kilograms. So we know that is our mass. We have a change in speed. And so remember, the energy is how much energy is used to change speed or to maintain that speed. So the change in speed, we have 18, subtract 3, which is 15 meters per second, is our speed. And then it's calculate the kinetic energy. So that is what we need to find out. So again, go through the steps, check in a minute. So hopefully you've written down that our kinetic energy is equal to 1/2 times mass times velocity squared. Remember, it will be easier for you to remember the formula if every time you write it down, you think of it not as EK equals 1/2 times mv squared. If you think about it, kinetic energy equals 1/2 times mass times velocity squared. Say it like that in your head, and it will make it easier to remember once you get to the test or the exam. So our kinetic energy is our unknown, times 1/2 times our mass is 300 kilograms, times our velocity is 15 meters per second. We need that squared. So again, we plug that into our calculator, 15 squared times 300 times 0.5. We end up with an answer of our kinetic energy is equal to 33,750 joules. No unit, no mark. So again, 1 mark for a formula, 1 mark for plugging in the numbers, and 1 mark for our final answer. Question 4, I'll let you give it a go by yourself. There's one thing I want you to watch for, is that it's a ton, which is not the SI unit, not the scientific unit, so we need to convert that to kilograms, and it tells you how to do that there. So give that a go and come back. So we have 1 ton, so we know our mass is 1,000 kilograms. We have our speed of 8 meters per second. Kinetic energy is 1/2 times mass times velocity squared. So this is 0.5 times 1,000 times 8 squared. So we end up with a final answer. Our kinetic energy is equal to 32,000 joules. Here, our next one, again, so this one is actually worth 4 marks, 1 for conversion, 1 for the formula, 1 for plugging in the numbers, and 1 for writing out the full answer. On a test, if you simply plug something wrong into your calculator, which we've all done before, we all make that mistake, and you only write down this number, you will get 0 marks because you're writing down the wrong answer. If you, however, do every other step and you just plug the number wrong into your calculator, or you hit multiply when you meant to hit divide or something along that lines, you will still get 1, 2, 3 marks out of 4. So please make sure you're writing down all the steps, get into the practice of it, so when you do it on an assessment, you just get into the habit of it. I actually lost marks because I didn't do it when I did my test in my A-levels, essentially. So, question 5. If you're feeling good about it, crack on, do 5 and 6 and 7. Pause the video now and come back. Speed ahead to see the answers. We'll go through 5 and 6 and 7, will be on your own if you are struggling a little more. So, one thing to notice, convert kilometers to meters per second. You should know that with the kilo means 1,000. So there are 1,000 meters in 1 kilometer. So when we are at 7.5 kilometers per second, that means it is 7,000. So we multiply that by 1,000. So we're at 7,500 meters per second. With that, you should be able to do this example. So go through it, pause, give it a go, pause the video, and restart once you have the answer. So, as any other one, we start by looking for what we have. So, calculate the kinetic energy. That's what we're looking for. While it is in orbit, so we have our mass, we have our orbital speed, or the speed in orbit, and we don't need to know the other ones. So then, step 2, write down our equation. Our kinetic energy is equal to 1/2 times mass times velocity squared. Plug in our numbers, equals 0.5. Our kinetic energy, 0.5 times 78,000 times 7,500 500 squared. So you end up with a final answer here of 2.19 times 10 to the 12. So in your calculator, it might have looked like 219, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, with a whole bunch of other numbers here. So I'm just going to put zeros in, but I think there were other digits in your calculator. This is a really big number that we're not going to use. So we move the decimal point 12 spaces to get to this scientific notation of 10 to the 12. All right, so this is another example where we will use it. And again, remember, no units, no marks. So again, here we have 1 mark for the conversion, 1 mark for the equation, 1 mark for plugging in the numbers, and 1 mark for the final answer. So even if for some reason your calculator wasn't letting you get to this final number, you can still get 3 out of the 4 marks. So question 6, give it a go. I'll go over the answer in a moment. So hopefully you've pulled out that the mass is 12,000 kilograms. The velocity is 12 meters per second. And we're looking for the kinetic energy. And I looked at it very quickly and I didn't realize it's changing the speed. So from 12 to 18, so we have 18 meters per second, subtract 12 meters per second, we end up with 5 meters per second is the velocity that we're actually looking for. So our kinetic energy is what we don't know, is our question mark. So we plug in our formula. Kinetic energy is equal to 1/2 times mass times velocity squared. So our kinetic energy is equal to 0.5 times our mass 1200 times 5 squared. Again, you plug that into your calculator and we end up with an answer of 1,500 joules. Looking at this, you could, if you wanted to, convert this to scientific notation of 1.5 times 10 to the 4 joules, but you don't need to, unless it asks for the answer in scientific notation. All right, so now I'd like you to try question 7. Just going to pop up the answer in a moment. Hopefully you have it. So hopefully in this last question you caught the conversion you need to make, because it asked for it in kilojoules. So in order to convert from joules to kilojoules, you needed to divide by 1,000. So our final answer is 900,000 kilojoules. All right. If you've left your answer in joules, and here I'll add the J because no units, no marks. If you've left it in, you'll miss out on 1 mark, but it'll still be 1 mark for the formula, 1 mark for writing in the correct numbers, and 1 mark for solving that. And then your 4th mark is for converting it to kilojoules. So that was a lot of questions, a lot of marks, but you'll see it's not too hard to collect a lot of marks on your physics exams using just these steps. So here are 2 more questions. I'm not going to go over the answers to them. Give them a go if you would like to, for some extra practice. If you're stuck, email your teacher about it. Next, we're going to look at what if we know the kinetic energy, but not the mass or the velocity. So there's one way of doing it that's memorizing a whole bunch of equations. I know how much you all love memorizing equations, and there would be so many, so we're not going to do it that way. I'm going to show you the maths way of doing it, which will always get you the right answer, even if you can't remember. It'll literally multiply your equations that you have to memorize by 3. You already have to memorize so many, and this system just works. So, looking at the question, what is the mass of the rock? So we first come across our mass. This is our unknown. We don't know what the mass is of a rock that has 300 joules of kinetic energy. So we know this is our kinetic energy. And a velocity of 10 meters per second. So we know this is our velocity. So step 1 doesn't change. Step 2 is write down the formula. That also doesn't change. So our kinetic energy is equal to 1/2 times mass times velocity squared. Plug in the numbers. Doesn't change. So kinetic energy, we know that. That's 300 joules. It's equal to 1/2 is 0.5 times our mass. That is our unknown, so I'm going to leave that as m, times velocity squared times 10 squared. So now it's a case of collecting like terms and getting m by itself. So there's 2 ways you can do it. It doesn't matter to me. You can either move everything over to this side of the equation by dividing, or you can multiply them together first, which is the way that I like to do it. So I tend to go 300 joules is equal to, I know 10 squared is 100, times 0.5 is 50 times our mass. If 50 times m is 300, what is m? We're multiplying here, so to move it across, we divide it. So we know mass is 300 divided by 50. So we know our mass is, when we plug that into our calculator, 300 divided by 50, 6 kilograms. No units, no marks. So this is a 1 mark for writing down the formula, 2 marks for plugging in the numbers, 3 marks for moving things around as you need to, and your 4th mark for your answer. So looking at this next question, give it a go, doing the same type of thing. Pause the video, give it a go. So this on an exam would be a 5-mark question, because with a velocity 10 meters per second, so we know our velocity, 50 kilojoules of kinetic energy, we can't use kilojoules into the equation because it's not the SI unit. So we have to convert kilojoules to joules. Kilo, 1,000. So this will turn into 50,000 joules. What is the mass? So our mass is our unknown. So step 1 completed. Step 2, it doesn't change. Kinetic energy is equal to 1/2 times mass times velocity squared. So we end up, we have our 50,000 times 0.5 times our mass, which is what we don't know, times velocity, which is 10 meters per second squared. So again, 10 squared is again 100 times 0.5 is 50. Oh, there should be an equal sign. So we have 50,000 is equal to 50 times our mass. So our mass is equal to 50,000 divided by 50, which even without a calculator, I can easily tell you is 1,000 kilograms. No units, no marks. Okay, so this one, we would have a 6 mark. 5 marks, as I said. 1 mark for the conversion, 1 mark for the formula, 1 mark for plugging in the numbers, 1 mark for rearranging, and 1 mark for the answer with the unit. Okay? Feel like you're probably getting the hang of this. So we're just going to step it up a notch. Again, I'm going to get rid of this equation because you don't need to memorize it. It goes the same way. So give it a go. We're now putting a square, reminding you what is the opposite of a square? Yes, a square root. Notice the first one there does have a conversion. So giving it a go, pausing the video, coming back. So looking at it, we have our 8 grams. We can't use grams. So we know we have to convert it to, well done, kilograms. So, which is 0.008 kilograms because we divide it by 1,000. to get to the kilo. Fired from a gun where it gains 490 joules. This is our kinetic energy. How fast is it moving? If it's asking how fast, we know we're looking for the speeds. So we've done our converting grams to kilograms. So step 1, write down your equation. Kinetic energy is equal to 1/2 times mass times velocity squared. We have our kinetic energy is 490 is equal to 0.5 times 0.008 times velocity squared. So now we need to multiply these two together. When we multiply those together, you can multiply them together and then divide, or you can just divide them both over. So I would go 490 divided by 0.5 divided by 0.008. It gives you velocity squared. Plug that into a calculator, you end up with 122,500 equals velocity squared. Remember the opposite of squaring. We have to take the square root to get the velocity on its own, so we have to take the square root of that side. So velocity, once you take the square root, is 490. So a ball of mass is not 490. Looking at the wrong number. We have 350, and I forgot my unit, so I wouldn't have gotten that mark, meters per second. So here we'd have 1 mark for the conversion, 1 mark for the formula, 1 mark for plugging in the numbers, 1 mark for rearranging it, and 1 mark for the answer with units. So if you had done what I did there and just written down the wrong number, you would still have gotten 1, 2, 3, 4 marks out of the 5 marks for the question. So it is always worth writing down all of your steps. All right, question 2, giving it a go, doing the same steps. So here we have that final answer. 1 mark for the equation, 1 mark for plugging in the numbers correctly, 1 mark for moving the things around, so that's these 2 steps together, and 1 mark for the final answer with units. No units, no marks. I know I seem extra when I ask you to write down all the steps. It is to make sure you get as many marks as possible. So now for an extension activity, if you'd like some more practice, there's some questions here to continue on with. They're in your booklet online, so just have a look at those. If you need to, you can submit those answers in and I will correct those, or your teacher will correct those. Otherwise, to finish up the lesson, just give these knowledge check questions a try. So here are the correct answers for this final knowledge check. 7 and 8 took a couple steps for you to do, just showing how you move them across. If you needed those steps, that's absolutely fine. If you were able to get straight to this in your head, that's absolutely fine as well. Don't forget for helium, first letter capital, second letter small. Potassium is the weird one. It's K, not P, because P is phosphorus. Hopefully you have that all in. Any questions, email your teacher. Don't forget to do any other tasks that your teacher has set, such as an Educate quiz or any other type of quiz. And we'll see you for your next lesson.